Yo, what's up, guys? Welcome back. Another video. Shout out Get Up followers. Yesterday, oh, oops. Yesterday I said I was gonna continue. I was gonna do some work on the project, and I just never did. Like procrastinated till the day was over. You know how it is. It's okay. Today we're gonna try to get in 2 hours. That's my goal. Cause I got a lot of homework to do. I gotta write I gotta write 2 papers, and I gotta study for a midterm. So let's make the Pokemon sound of the day. That Pokemon today is Venomoth. So let's take a listen. What? Can't even hear what he's saying. Alright, let's get into the Leetcode of the day, shall we? Let's try to just do one. It's at 270. We got shortest subarray with OR. Is this another bitwise? Dude. I'm really not trying to do dude, it's been like 4 bitwise questions in a row. I don't want to do these. I mean, okay, I don't even think this is a bitwise problem. This is like a, but like, I don't really understand how bitwise OR works. So like, why, you know, like how would I check all the subarrays? It's ridiculous. It's greater. Is at least K. Turn 1. Okay, well. The problem is like if you do like a print like 1 or like you do like a 3 or wait. See, like, why is the 3 or 5? But if I do like 3 or 6, 7, 11. Will this number ever go down? Okay, I have an idea. 4. I'm just like, just doing some experimentation with bitwise operations right now. Oh, they do never go down. What if I do like 2? Oh no, they do go down. But like, It is a sliding window. I think that TLE is on n squared or something. I mean, I don't know, like I have no idea, like curve. I mean, I don't know. Like, I don't know the sliding window. Like, I'm just guessing. Like, if you OR with more numbers, does the number just kind of grow? It does, right? Oh, I know how to do it. Okay, so if um I don't need a cur max, I need a min size. Okay. Yeah, so basically what I'm gonna do, I think I know how to do it. Um um what I'm gonna try to do is basically I'm gonna have a left pointer and a right pointer. All right, they both start at 2 here. And as I'm gonna keep adding, I'm gonna keep the right pointer moving to the right until it reaches k equals 10. Okay, so it's not gonna be here or like these or together. It's gonna be too small. Once it gets to here, all of these, this is greater than 10. All right, according to the example. So then I'm gonna attempt to move the left pointer to the right the moment it's over. And if that's not true, then you move the right pointer. So hold on. If the window is greater than k, move left pointer. If window greater or equal to, if window is less than k, move right pointer. Can I, how? undo an or? Can you undo an or? That's not good. That's really bad, actually. Because I can't move the pointer to the right simply then. I mean, I can just do... Okay, I want to do this. Def... Nine. One. Okay, it is. Nice. Why did I put brackets? Huh. Is this doing what I think it's doing? Oh, it's the minimum. Am I tripping? Hold on. R minus plus 1. There you go. Jesus. This is still gonna TLE, by the way. But yeah. Man, this is how you do it, but the checking needs to be O of 1 and not O of n. This might be n log n for all I know. Yeah. But I think this is the right idea. So let's just watch the Leetcode video and it'll be cool.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem, shortest subarray with OR at least K2. So this is actually a relatively easy problem, and I'm not saying that to make you feel bad about yourself if you weren't able to solve it. I'm saying that because I know for sure that one day you will think that this is an easy problem as well. I'll show you the exact thought process that you need to be able to solve this kind of...
I agree with him. I bet it is easy. If I knew anything about bitwise operations, it's probably easy, bro. Like, I guarantee you his code looks pretty similar to mine. It's just the way he's, like, updating. It's a very basic sliding window. It's, like, the most basic sliding window you can get.
Without failure. I can show it to you because it's actually pretty easy. And the main reason that I'm able to recognize that this is an easy problem is because I have a pretty deep understanding of this pattern of problems, like this pattern of sliding window problems. They all have significant overlap. For example, these two problems are very, very related to today's problem. I'll be using the intuition from the solutions.
Yeah, I understand that. Yep. Look at that. You got the R pointer and you got the
to actually
easy, bro.
Explain today's problem. And I'm not just mentioning this as like a shameless plug for the website. I know most of you know about this already. I just think it's so important to be able to relate similar problems together, because if you don't, then you always feel like there's some random trick that you just don't know, but actually there is significant overlap. Suppose we're given an input array like this one, and we're given a k value, 10 in this case. So somewhat similar to the example down here, we want to return the smallest special array. So some subarray from this one, it has to be continuous. We want to minimize the length of this special subarray and then return that length, not the subarray, but the length. Now, what exactly is a special subarray? Well, if you take the bitwise OR of the subarray, so this subarray, bitwise like binary 0 or binary 1, sorry, is something like this. Binary 8 looks like this. And if you OR two numbers together, this is very important, or will never unset a bit. It will only set
I understood
a bit.
that.
So if you take these two numbers and OR them, if there's a bit set in any of those numbers, then the bit will be set in the output. But if it's not set in any of them, like all of them don't have that bit set, then it's going to be 0. So it'll be 0, 0, and then a 1 over here. This is binary 9. So that means if this subarray has an OR of 9, it's actually not a special array, because special arrays have to have an OR greater than or equal to the k value, and this is not. But if we look at this continuous subarray, if you look at the bitwise 2 and bitwise 1, but that's actually not necessary. In any case, if you OR all of these together, I think you'll get something like 11. And so that is, of course, greater than or equal to k. So this is a special array. The length of it is 3. So now that we know what the problem is, the brute force solution would just be to check every single subarray. Perhaps starting at this one, we go like this, 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 and just keep going, right? Nested loops. Then start from here, do the same thing, just a couple nested loops. And the problem with that is that there are n squared subarrays. Yes, for each of them, we can get the OR in pretty much constant time, and then just do the comparison. That's easy enough. And yes, this is a working solution, but we can do better. Now, this is my process for solving a problem like this, or rather optimizing the solution. Think about what I'm about to say and listen to it very carefully. This brute force solution is, yes, looking at every subarray, but more specifically, this is what we're doing. We're checking, is this subarray special? Is this special? Etc., etc. Do you notice any kind of repeated work or maybe redundant work? Like, that's what you should notice. And it's not something you're going to automatically notice. You specifically have to ask yourself this question. Is there repeated work? Is there something redundant? Yeah, there literally is. Think about this. If I found that this is a special array, what I'm really doing when I have like nested loops for I and then for j, the I pointer is the left. And I'm basically getting every subarray starting from here. Once I find a special subarray, I don't really need to keep going because I already found the shortest subarray starting at this position. So next, I want to find the shortest subarray starting at the next position. And that's literally the solution to the problem. Now I just told you how to optimize it to a linear time solution. Wasn't that observation pretty simple to make? Like, why keep going? Like, if I found that this is a special subarray, why would I care?
But that's still n squared, like, worst time.
No, if this is a special subarray, I don't care. This is of length 4. The other one was of length 3. I'm trying to minimize them. So you just have to look for an observation like that, and you have to specifically look for it. It might not just come magically by reading the problem description 10 times. Take out a piece of pen and paper, take some notes, pause the video if you have to, do whatever you need to, but do not skip this step. Do not skip it. So now, how does that observation
but I still did that,
help us solve the problem? Well, this is what we're going to do. We're going to basically have those same pointers, I and j, but instead of having them in 2 separate loops, nested loops, we're going to have them together. So I'm going to have my 2 pointers, pointer here, and the right pointer will be here as well. So 2 pointers, we'll check the OR of this. It's 2, it's not greater than k, so we are going to shift the right pointer now. We're still
I did the exact same thing, dog.
A window that is special. And it's important to know that this works because OR, like I said at the beginning, is only going to make a number bigger, not smaller. It's only going to set a bit, not unset a bit. So that's another like important observation you have to make. You have to intentionally make these observations. And so we're still going. We're still trying to increase the array because we're trying to increase the number. So then we go here. And then we'll find that, okay, the OR now is equal to 10. Okay, so right now my number in binary looks something like this. Okay, so now we're going to shrink the window, right? This is where
okay, great. How do you do that?
So now we shrink
with
the
OR
window,
binary,
we shift the left pointer here.
Okay.
So now we want the OR of just this. How do we undo that? How do we get rid
Watch, this right here, he's going to explain this. I'm going to solve the problem within 5 seconds. Ready? Watch.
Of this? We know that binary 2 looks like this, 0, 0, 1, 0, specifically this part. That's binary 2. The naive thing to do here would be to say, okay, so if we're removing 2, then we want to undo the OR that we originally did, which set this bit. So, okay, so that means we want to unset the bit. We want to change it back to a 0. And yeah, that does make sense. But how do you know that something else didn't actually set that bit? And I'm not just talking about another 2. For example, if we had another 2 over here, and then we like shrink the window, we get rid of this guy, technically this bit, the bit over here, should still be set because we still have a 2 in our window. So this is kind of a problem, right? Like I said, it's not just 2 that might set this bit. The number 3 in binary looks like this. So that's also going to set this bit, and it's actually going to set this bit as well. So what do we do? Well, if you've gone through a comprehensive list like this one, you'll probably know the solution, specifically the one from this. Rather than just knowing if a bit is set or unset, which is kind of similar to this problem where we have like a hash set which either contains a character or it doesn't, we can do the solution from this problem, which is slightly more advanced. Instead of using a hash set, you have a hash map, which counts the instances of a character. So then when you shift your window, rather than getting rid of a particular character, you decrement the count of it. So in our case, we are not dealing with characters, we're dealing with bits. So we have 32 bits in total. Generally, that's a safe assumption. We're dealing with 32-bit integers in this problem. So rather than setting and unsetting a bit, which if we were doing it this way, we could just have like a single integer, that we could maintain. But now, rather than doing that, I want to know the count for each bit. So I could use a hash map if I want to do that, but I can also use an array of, let's say, size 32. And so each one of these will correspond to some bit, kind of like this. And rather than just being ones and zeros here, some of these might be 2 or 3, depending on the number of times a bit has been set. So enough talking, let me show you the solution now. So we were at this window, and technically, like, our counts were 1 for each of the bits. So then I can shift this pointer over here. We get rid of the 2. We would decrement that by 1. And now we're here. So this number is 9. It's not greater than or equal to k. So far, the smallest window we found is of length 3. We will now try to shift the right pointer. It's going to be over here. We take the number 4, which looks like this in binary, or it here. It's worth mentioning how exactly are we going to do that, because remember, this is an array now, and we have a number over here. So we can't just do the OR operation. It's not going to be that simple. What we're going to do is, for each of these bits, we're going to look at it. If it's a 0, we're going to look at the corresponding position, increment it by 1. Or sorry, if it's a 1, we're going to increment it by 1. If it's a 0, then we're going to increment it by 0, not do anything. So in this case, this is the only bit that's set. So that's the bit that would be set in the results. So scribbling this out, we will now have this. And this number is greater than or equal to k. So this is a window of size 3. But now let's try to minimize it. Let's look at this left pointer over here. And we see that this is already a special window. So let's find the special window starting from here. That is the smallest. Shifting the pointer, we're here now. And when we do shift that pointer, we want to decrement the count of all the bits that are set in this number. This is binary 0001, so we want to decrement the count of this bit, so it will now be set back down to 0. This number is greater than or equal to k, so the smallest window we found is of size 2. Once again, we will shift the window. I'll kind of draw all this. So I'm going to take this left pointer, shift it over here. The bits that were set were these. This is 8. It looks like that, so we unset that bit, and we will end up with this. And this number is this window, and it's not greater than or equal to k. So now we can try to find the window starting from here that is special, if one exists. So now we're going to take our right pointer and shift it over here. This is 11, so I believe in binary it looks like this: 8, 2, and 1. So we'll take each of these bits, add them there. I think we'll end up with this. This is valid. This is greater than or equal to k. This window is valid. It's of size 2. So now let's try to shrink it, try to find the next special window starting from here. And for us to do that, we have to unset the bit over here. So this will turn into a 0. This is this window. It's also greater than or equal to k. So this is the smallest window that we found, the one that starts at this element. And if you notice, this process, this algorithm actually did find the smallest window starting from every single position. If that's what we were looking for, we could have done that and returned that instead. But that's not what we're looking for. This is a relatively simple sliding window problem with some bit manipulation tricks added. And those bit manipulation tricks are going to be easier to explain, I think, in the drawing explanation. They're not really tricks. It's just some conversions. Time complexity here is going to be linear constant space. So I'm going to initialize my left pointer to 0, and for my right pointer, I'm going to just have it in a for loop. It's going to be incremented every single time. Inside of the loop is where we will update the left pointer. This is a pretty classic sliding window template. The result we're trying to return here is the length of the smallest window, and it's actually possible that we do not find the smallest window. So in that case, we would want to return -1. So I'm going to actually set this to a really large number, infinity, so that we can try to minimize it. But if we don't, I'm going to return -1. So return -1 if result is still equal to infinity. Otherwise, return the actual value that we found. Now, in this loop, remember, we actually have a array that we want to maintain. I'm going to call that bits. I'm going to make it of size 32. It's going to be all zeros initially.
Okay.
Now, inside the loop, we want for the current number, nums at index r. For every bit set in there, we want to increment the count here for this variable. So I'll go ahead and do that right here. So I'm going to go for I in range 32 times. We at the very least know we got to check like all 30.
That's true.
Bits. Well, I guess you don't necessarily have to. The main reason I'm doing it this way, like we could have alternatively done something like this while, let's say, nums of r is greater than 0 and then constantly shifted it to the right inside of the loop. But we also want to know the position of each bit. That's why I'm using I, because inside of this loop, I'm going to do something like this, bits of I. I'm going to set it. I'm either going to increment it or whatever. I want to increment bits of I by 1 if the ith bit is set in nums of r. How do I know if that's the case? Well, if nums of r ANDed with the ith bit is non-zero. And we can get that pretty easily like this. Just take 1, shift it to the left I times. Initially, this will be 0. That'll give us 0, 0, 1. Then we'll shift it by 1, so that'll give us this. And then we'll shift it again. That'll give us this, etc., etc. So we go ahead and do that. Now,
if nums its part...
Now, we want to actually take these bits and compare it to k. Is it greater than or equal to k? Is bits greater than or equal to k? The problem is you can't compare an array with a number. So what I'm going to do is convert the number into an integer. I'm going to call that integer the current or. I'll initially say...
Wait, if nums its part r... Okay, I mean, if nums its spot r is ANDed with... Wait. So I don't really know what the shifting does. No, I get it, kind of. Bits, its spot, what is it, R? No, S spot I plus equals 1.
Set it to 0, and I will go.
I see. I see.
Through every bit, just like I did right now up above.
It's like 32 again right here.
In range 32. And then I want to take that bit. If it's set, the ith bit is set, then I want to take it and add it to the current or number up above. So to current or, I want to add the ith bit. This is the ith bit.
Is it or equals? Or equals what?
1 shifted to the left by I. So now I have my current or. That's what I'm going to use.
Yeah, I don't really get that. That's what I don't really get.
To compare.
This would I would have never solved
Inside
this.
of here, I want to update my result. I want to minimize it, so it'll be the minimum of what it already is and the current window, which is this.
If cur or...
And if it's valid, then I definitely want to increment my left pointer. And if I increment it, I want to actually then check this condition again, because maybe this array is already special. If it is, we don't need to try to increase the array. Why should we try to do that? We want to find the next special array at the next element. So actually, I'm going to change this to a loop, a while loop. And before we increment the left pointer, we should take the value at the left pointer, nums of L, and remove it from bits of I. Well, this loop up here added it to bits of I, added a particular number, nums of R. So now we want to take nums of L and remove it. We could kind of take this code and just add it here. It's a loop, but it only runs 32 times, so it's not inefficient. But we could also modularize this code if we want to. You can create a function like this. I will call it a bits update. So it'll take the bits array, and it's going to take a number. Now, the problem here is that here we want to increment the count of bits of I for each bit that's set in the number. But down here, we actually want to do the opposite. We want to decrement bits of I for each bit set. So I'll just pass in a second parameter, because we're either going to be incrementing by 1 or decrementing by 1 for the bit set. So I'll call it the diff. It'll either be +1 or -1. So now I'm just going to cut this code actually, and put it up here. I'll replace this number with the diff. I'll replace nums of r with n, and bits can stay as it is. So now I'm going to replace the code that was here with the function call, passing in bits. It's passing in nums of r, passing in +1, and then I'm going to copy this and do the same thing down here, except this is going to be nums of L. This
But how you're not ever updating cur
is
or?
going to be -1. And since we updated bits, the loop is going to execute again. We're going to check this condition, but now current or is out of date. Current or should be in sync with the bits because it's just the integer representation of the bits. So now I have to copy and paste this code inside of here.
Yeah. Okay.
Or I could put this in a function. So that's exactly what I'm going to do. I'll call it take the individual bits and convert it to integer bits. To integer, because that's literally what this is doing. So give me some bits and it will return an integer. So I'll call it result. I'll just cut and paste this here, replace this with result, and return. The result. And now this code down here can be replaced with the function called bits to int, passing in bits, and then down here, after updating this, we can also update current or just by kind of copy and pasting this line down here. I hope by explaining my thought process and refactoring this code, even though I know the video turned out longer than it probably needed to be, if you're a beginner, I hope you realize how these solutions that people come up with, it's not magic. There is a thought process many people are following. Ooh, and somehow I forgot that we want our left pointer to never be out of bounds. Like this loop is incrementing left, and specifically it can end up out of bounds because there's an edge case where k can be equal to 0, in which case our current OR will also be equal to 0. And then like this loop will clearly run forever because that will always be greater and this will keep incrementing. So to avoid that, let's add the case where left is less than or equal to r. We don't want that pointer to cross the other pointer.
What the? That's actually crazy. Look at all. I've never seen it like that. Yeah, that was a tough. I mean, yeah, it's just this chip thing. I understand the sliding window. It's just all these bitwise operations I don't really get. That's the problem. I do be at 270 though. All right. Let's get on to the project. So I think it's mostly done. Wait. It did work, but it just like added that weird thing at the. Right. Okay, so when I add from the song search, it needs to never do that. I mean, right here, this add playlist should not be. Oh. And I don't know. This should never be being used. I think that's the problem. Or maybe it should be. Get VBox. Okay. What if I... Wait. Was this always here? Wait, it deletes it right as I click on one of them, though. Yeah, that's not good. I have no idea how to fix this. This should never be appearing. This box here. No song selected. So where is this coming from? See, but if I select one, then it goes away. But why does it go away? That's what I don't really get. If I click on a song in the playlist, it goes away. That doesn't make sense, though. Like, why would it go away? Play song current index. What? This right here should never be being added, I think. Song controls, right? Like, why would I need that, right? Right? Right, guys? Oh. It's not there anymore. It worked. Okay. Now let's try to add a song to second playlist. Oh, fixed it. Okay. Nice. One sec. All right. Nice. All right. I mean, I think it's done, no? Like, I have all the functionality I want. I'm trying to think what else. Oh, there's a bug where I can't right click and it's not a bug, but I need to fix that. That'll probably be an easy fix. But it's basically done, and I just need to style it. And I just really don't want to style it because that sounds like such a pain. Oh, and it's way too bright. Hold on, I just need this. Create a menu. Nice. Okay, fixed. Fixed. I mean, now it's just kind of like how I want to. I need to style it now, so I have an hour to style it. Man, I don't even know how I want this layout. I feel like I kind of want. I want this stuff to be at the bottom. So okay, I guess I'll just do it like this. So I want the song. So this is my application. It doesn't even need to be this size, honestly. So I want the search to be right here. Um I mean, I guess it's the playlist right here, right? And then what, the queue right here? And then the sound thing right there. Am I missing any buttons? I mean, I think that looks pretty good, no? And then maybe if I'm feeling like super tryhard, I can add the waves here. You know what I'm saying? Like the sound wave. Like these things or something like that, you know? We'll look at that. So that means, do I need to separate the queue and the... Okay, where is get layout being called? Layout. But that's this one. So I need a dot get. Current song dot get layout. Right, it's right. It's being called right there. So the problem is that this layout, this VBox needs to be Q. And then we need a private VBox song controls. Q might have been a very bad word for this, as I am getting very confused. Okay, I finish this. Okay, so I need to... Yeah, so yeah, so get songs. So yeah, it makes sense that you add this to the queue. Okay, but this you add to the song controls. Which means I need to... Do I need to clear them here too then? Probably. But I just have no idea how to move them all the way down. That's the problem. Like, I have no idea. So, I don't know. Maybe this should be like public or something. I don't know. This should be public. No. I'm just gonna move it. Like, I'm gonna hard code it in. It's gonna be fine. This is gonna do the exact same thing, right? Except the current song is up here, and the queue is below the player. That's weird. Oh, because it's here. Wait, why am I doing this here? Why am I not doing this? No song. Why is this below it? Do this reverse. Okay. There we go. No song selected. This just needs to be at the bottom. This whole thing needs to probably just be way smaller. But I just have no idea how to get started. Like, yeah, this is gonna be a little bit tough. All right, I'm gonna ask. Oops. Scene.get styles. Yeah. Oh, and why don't you take a look at that? Take a look-see. Okay. That's obviously not what I want, but it's connected. Okay. Yeah, I wonder what this does. One, two, three, four, five. Oh yeah. Okay. Okay. All right. I'm gonna try to do as much styling with AI as I can. So let me just do that. All right. Oh. Mhm. Right. All right. Let's see what he comes up with. Public song search, songs folder. Hold on. I gotta add the get style, get class, all this horseshit. Okay. Song field. Song names. Layout.getStyle.getClass. Search container. That makes sense. All right. Let's see what he cooked up. Wait, this is vibes, huh? Region spacer. Yep. I don't know what this does. Is this about to fix it? What just happened? No. Wait, hold on. No, duplicate children? Yeah. What is that? First time in HBox song section? Song name, add song. Remove the parameters here. Got it. Yo, this looks fire, no? Am I tripping or does this just look really good? Oh, and the button's gone. And the button's gone. There it is. That is not... Okay. Void on change. Yeah, I don't think this is a... Wow. Can't even complain. Looks amazing. You're back. Now I want to move on to the second part, which is the playlist. Java, okay. Okay, let's go there. Does this still work? Okay. Let's see what this gives us. Where did this come from? God damn it, where is it doing that? But it's gone now. Like, I'm okay with it looking like this, honestly. It looks fine. But where is it getting this? My fucking god. Okay, it's okay, it's coming somewhere from here. What's it called in here? Get layout, okay? Get layout. That's not the right one. Bro, what? What did I do? Like, I don't even know what I did. Okay. I can mess with that. Okay, I can mess with that. Delete this. Get music controls. Here we are. Get music. This shit should never be called. This is the worst function ever right here. I'm going to get rid of it entirely. Wherever this function is called, I know I'm doing something wrong. All right. Okay. HBox controls. Delete all this. We don't need that. And then up here, HBox controls. Nope. Nope. With no problem. Okay. Okay. Yeah, bro, that really worked, dude. That really fixed it. I think this needs to be at the bottom. Nope. Is it? Okay. Um. Yeah. Okay. I think I know the problem. All right. That's not good at all. Oh, it's going. Okay. What is it? It's called currently playing. Oh wait, this isn't working at all. Dude, where is this gray coming from? Like that ass. Bro. What? Wait. Huh? Ew, it is working. It's just not updating. Oh my god. Okay. Okay. Hmm. So it is working. It's just weird how it's not. Current index. Fuck. Why not? Why not? Why no work? Why no work? But it's being called though. That's the weird part. Like I'm like literally calling this VBox function and it's okay, hold on. Okay. Is it main controller? It's slow. Why is it so slow? What is being called here though? Like what's the difference between these calls and just the in the playlist calls? That's not. Oh, but that's not gonna work anyway. Yeah, this is stupid. I don't need that anyway though. Yo, facts. I don't need this shit at all. In a nice way. And look, it's highlighted. It works just the way I want it to. No, this is fine. This is like completely fine. Okay. All right, let's just go to the last thing, the playlist catalog. Playlist catalog. It'll be fine. Also in your constructor. All right, that looks good. All right, I need to use the bathroom. Give me 1 second. All right, we're back. All right. Oh, there's no sound controls anywhere. Huh. Well. Hmm. Gotta make them public. Yeah. I don't really know what this is about to do, but hmm. Let's make this a little. Let's make it 700. Okay. Controls container. I have 2 controls container. Which one do I keep though? Dude, JavaFX was not meant for this. This is an afterthought if I've ever seen one. Oh, why can't I just change? Wait. Wait, why can't I just make this an H? Huh. That get layout. Okay. Huh. Required type VBox, provided HBox. Yo, am I tripping? Oh, it worked, kinda. This box stay changing now. Okay, I think this is probably a good place to stop. I gotta do so much homework. So we're gonna commit that. It's gonna be dope. So close to being done. All right. Peace.